All right, my name is Glenn Sizemore. I'm a senior technical marketing architect here at VMware in our storage and availability business unit, and I'm responsible for all things storage in the VMware Cloud on AWS service. This morning I'm going to start us off by going through a quick introduction of what the compute side of the problem looks like. We're going to break it up by the different disciplines, compute, network, and storage, as we walk through today. So starting off with basic capabilities, when you deploy a organization inside the service, this gives you the ability out of the box to deploy two software-defined data centers. A software-defined data center is linked to the region that you initially deploy it in. We can add clusters to that existing deployment, but those clusters are going to exist inside whichever region and availability zone was designated when you deploy the first cluster inside that software-defined data center. By default, organizations are limited to 2 SDDCs per organization, but we can increase that limit. It's a soft limit. You just contact support, and if you need more than that, we'll talk to you and help you work through it. Each cluster scales from 3 all the way up to 16 nodes, right? So quite a bit of flexibility therein. And then the other thing to note here is that the management workload for this SDDC is stored on the SDDC itself. So we don't maintain centralized management clusters where all your virtual center servers and NSX components reside. This is true hosted private cloud, right? Everything is residing inside the bare metal hardware that the customer is paying for. And that includes the management workload. Now, that management workload is restricted to the first cluster that is added to the SDDC. Every subsequent cluster that a customer chooses to add is purely for customer workload. So we don't use that for anything on the VMware operations side of the house. As for an actual hardware capabilities perspective, we launched the service, of course, with our i3 Metal node with AWS. This is a dual socket Broadwell system. Each CPU is clocked at 2.3 gigahertz, and we get a total of 36 cores on the box with 512 gigabytes of memory. So quite a bit of resources. These are beefy boxes from a workload perspective. As Narayan introduced earlier this morning, we have recently begun to expand the service. We introduced a new instance type. We call it the R5 Metal host. This is a diskless host type, so I'll get into this a little bit more later when we talk about the storage side. But the other thing that's neat about the R5 Metal host is it's about 50% larger than that i3 Metal host. Where this is built off a Skylake service provider platform from Intel, but we have 24 cores in each socket, so 2 sockets, 48 cores per server, and a total of 768 gigabytes of memory. So again, significant amount of infrastructure when we get the service up and running. Now, of course, for some software, that's a bit of a problem, right? When you have 48 cores, there's certain applications out there that look at that and say, well, give me some money. You might run my software on each one of those cores, and I choose to license by core. So to help customers out there, when we deploy our clusters, we have the option to soft restrict the number of cores that are going to be available to that platform. So even if you deploy that R5 host with 48 physical cores, we can choose to designate only 8 of those as active to help control the licensing exposure. Yes?
And to clarify, that's just to help with licensing costs. It does nothing to impact the actual cost the customer is paying for the resources.
Yeah, correct. There's still 48 cores, and the base hourly cost of the resource is still what it is. But depending on some of the software out there, this can really make a difference from an affordability perspective, where the larger CPUs become a problem in some instances. But it's not a problem. Get the whole thing.
Is this recognized by some of the more notorious vendors out there? I.e., will they accept this solution?
Yeah. We're not going to name names, obviously, but yes, some of the more hard to play, we'll just say, databases out there play nicely and recognize the integration. We built this feature based on customer feedback, right? The customers came to us and said, hey, we love the service, but look what it's going to cost for me to move this application up there. Help us out. Right, so we had to go work with those vendors, figure out what was going to work, and our CPU core restrictions is the workaround for those scenarios. Regardless, though, we're going to take these hosts, whether you select that i3 Metal host or an R5 Metal host, and we're going to combine them into a cluster. As I said earlier, these clusters contain the actual management components used to manage the SDDC. So this is true hosted virtual private cloud if you choose. Scale again, 3 to 16 nodes. We can add or remove nodes dynamically as we need to. And then at the cluster level, we have enabled both vSphere availability and DRS from an operations perspective. Those are managed by VMware SRE. As a customer, you can view all of the settings. You can always see what we're doing inside your SDDC, but that falls underneath our responsibility. We manage it on your behalf. The actual availability configuration, as I mentioned, availability is enabled. We have host monitoring enabled as well. The admission control is configured on a percentage base, and that percentage base is updated as we add or remove nodes, right? So when you first deploy your SDDC, we're going to have it set to 33% because we only got 3 nodes. As we add nodes, we will decrease that admission percentage to try to guarantee that in the event of the loss of a host, we will always be able to restart your workload and get those VMs back online. We've also enabled the app monitoring and host isolation response. Out of the box, if a host detects it's isolated, powers down the virtual machines inside the cloud. From the DRS perspective, DRS again is enabled. Our migration threshold is set to 3. If you haven't seen the wizard in a while, that's right smack in the middle. From an aggressive standpoint. DPM is disabled, but we've done something slightly, I'd say, a little more sophisticated. We'll talk about it here in a couple of slides. We do implement resource pools to separate those workloads. So the management resource pool, everything that VMware Operations is responsible for resides in a management resource pool in a management data store that VMware SRE has full control of, and the customer administrator has view permissions, but that's it. And then conversely, the customer has their workload resource pools and compute data stores where they have full control of those resources. So that's where they put their data and their access. Of course, some of the things are, yes?
Quick question.
Sure.
All of these settings, you can't change these. These are set there.
Correct.
Where on-prem, you might want to fiddle with these, but these are your kind of defined.
Yeah, so this starts to get to, and we'll try to make this case over the next however many hours, but this starts to get to the real value of the service. When you show up with a workload inside VMware Cloud and AWS, we're not selling you a technology bag, right? We are delivering a production-ready vSphere environment that is ready for your workload right out of the box. And that includes us having to think about all of these various different settings and management skills that we typically ask our customers to do because they're designing their data centers on premises. In this case, we're running it for you, so it's our responsibility to worry about all of this stuff.
But if I have specific use cases, can I speak to your SRE team and get a kind of state migration threshold of 3 if I have particular sensitive workloads? Can I lower that to 2?
No, we don't.
Okay.
We don't. There's kind of the 2 answers to that, right? The first is just a straight up no, we don't allow that. The reason for it, though, is because the reality is our operations would have a really hard time managing the service if we enabled that sort of thing, right? But remember, 13 sites across the globe, how many various different languages we have to interact with, different applications and product support. This is very much a global implementation. So when we think about making a change to the SDDC, we're making the change to the entire fleet, every SDDC that we have deployed inside the service. And really this gets to kind of the 2-stage trade-off when a customer comes in, right? We're drawing that line between, that's why I kind of like this visual representation of it. We draw that line down the middle of the infrastructure and say, all right, Mr. Customer, we are going to worry and take care of the vSphere platform. You worry about your workload that runs on top of that. And there's some growing pains there for customers that are super vSphere experts, right? They look at it and go, well, I like 4, not 3. But the reality is we're asking you to let go of those fine details and instead spend that time thinking about your workload, right? Just kind of shift the focus a little bit. Now, we do have some advanced controls. We've had to rethink some elements inside the vSphere product in making this cloud ready. One example of this is the host affinity system, right? The way that it was implemented on premises does not work in the cloud at all. You don't have that level of permissions or exposure from a host level. It also is a little bit hokey to manage. The implementation and how it was designed worked at the time, but when you take a look at modern implementations, it could use an update. So our answer to this was to go ahead and take an advantage, take a fresh swing at the problem, and we developed compute policies. Compute policies deliver the same capabilities, but using a modern control plane. So this is all based on tags. We have VM host affinity and anti-host affinity policies. And the way that these work are fairly simple. If we want to pin a host to a VM, we simply tag the host with a given VM tag, and then tag the VM with a given tag, and then we go into the compute policies product and simply just say, hey, look, I always want tag A to be on host A, and then at that point, DRS will just do its best to honor that rule. These are should rules, right? So if it can't honor the rule, then of course it will put the VM wherever it can. But if at any point in time the cluster changes and it all of a sudden can honor the rule, then it will go ahead and vMotion that VM and get it where it's supposed to be. If we have workloads where we just want to simply keep them separate, of course, we can set our anti-affinity. And then finally, the disable DRS vMotion rule. This is mainly for large databases, right, and high production, high compute, high memory consumption workloads where we don't want vSphere to be moving them. We don't want to suffer any stuns. We don't want to deal with it, right, unless we're dealing with the host maintenance activity. If VMware SRE is rolling the host because it's patching our cluster, of course we have to move that workload. But this policy just gives the customer a way to tell that SRE engine that, hey, look, by default, don't touch this VM unless you're doing a maintenance activity. So it's kind of taking a fresh look at some of those controls and seeing if we can deliver the same root capability that customers demand in a cloud-friendly model, right? That eventually will show dividends on premises for customers that they also get to take advantage of these newer control planes. Speaking of flexibility, again, this is cloud. So one of those core tenets of cloud is to only use what you need at any given time. Don't ever deploy more than you need. It doesn't matter if you're going to need 100 gigs later today. Wait till later today to deploy it, because those hours matter when it comes to paying the bill. When it comes to the service, we empower you to treat hosts like that, and just think of cluster scale almost like artillery. You're just lobbing a request over the hill for VMware SRE to deal with. The host additions, as we shared this morning, they typically complete in about 13 minutes average, 15 at the high side. But it's complete. It's everything that needs to happen. So as soon as we get the host added into Virtual Center, we automatically extend those NSX networks, adding all the VM kernel ports, managing all of the network configuration. We then come in and configure the vSAN configuration, expanding the vSAN data store to pull in all that additional capacity. All of this is just handled for you on the back end. Yes?
Right. You said the R5 instances are diskless?
Yes.
So that means they're not participating in the vSAN cluster?
No, they are. We're going to talk about that in the storage section. They use a new special version of vSAN we call Elastic vSAN, which fuses Amazon's Elastic Block Store product to VMware vSAN. It's specific and special to that R5 instance. It still has the same semantics. It's just the storage isn't physically in the box because it's using EBS.
Right. Okay.
Just a quick question on the previous slide. Will you cover how those kind of compute policies are impacted around stretch clusters at all?
Well, what's your question about?
Well, I guess, can I mix storage policies in a stretch cluster that say I have VMs that are replicated and VMs that aren't replicated? So I could have a VM that's only on one site that I don't have the storage for in the other site?
Absolutely. Yeah.
So in that case, I'd want to be applying a compute policy that is a must rule rather than a should rule.
Well, it's always going to be a should rule. We don't have must rules in the service, and the reason that we don't have must rules in the service is because the problem with a must rule is it can block an enter maintenance mode activity, and the way that we do host patching inside the service is to always add new. We add a new host, and then we remove your old one. And we just slowly walk through the cluster. And if we allowed must rules, then there's the possibility for that EMM activity to be permanently blocked because someone has to manually go in there and move that.
But if
we don't touch customer VMs.
If the must rule was all of the hosts in that site, then you could still maintain that. The problem, so I've got some experience with just customers, and the problem with VMs that aren't replicated that only have a should rule is that in a site failure, that VM will be brought up on the other side and it won't have its storage there because it's not replicated.
Correct.
So we use must rules to pin that and make sure that that doesn't come up on the other side.
So great question. The way that this manifests, I'm not prepared to show it to you right now, but I actually have a demo I can show you when this is all said and done that shows exactly what the stretch cluster reacts in that scenario. The way that it will respond is it will bring the VM up on the surviving AZ. Now, since the storage isn't being replicated, vSAN doesn't have an active copy of the data. So vSphere will have a copy of the virtual machine, but it won't be able to power it on because the virtual machine's data is inaccessible. The instant those VMs or those host the hosts in the failed AZ come back online and the component objects are available, the VM powers on. So the whole time, the vSphere availability is trying to get it back. It's just struggling to power the virtual machine back on, but it can't because the storage isn't there. The second the storage comes back, it powers it back on. But it's not a must rule because, again, that would block our patching. And this kind of gets back to what I was saying before. We kind of have to rethink little things, not big things. For the most part, this is still just vSphere. But there are tiny little things like that where we have to go back into the customer and say, well, what are you trying to accomplish? No, actually, we can accomplish that, and here's how it works. Yes?
Just to clarify for me, if you lose an AZ, why do you wait for the hosts to come back in order to retrieve underlying EBS volume capability? How are the two linked?
So in the case of the EBS volume, they're not entirely linked. But in the case of our standard hosts, right, the vSAN storage is sitting inside the box. So each one of these boxes have 8 NVMe devices inside of them, and that's where your data resides. If that box powers off unexpectedly, all of the data that was on it is no longer accessible. So if we were relying on components that were stored there to make the vSAN objects available so that the virtual machines could run, then of course we're going to have an availability problem there. As soon as the host comes back, which that's where VMware SRE and AWS SRE, we have a real tight partnership on the back end in our support channels and really good visibility into what's actually going on inside their environment and what our ground truth is for our customers. Whenever we encounter challenges like that, we're working together to bring it back. And if we can, the second we get it back, you're going to get access to your data back.
But I think in that example, it's a bit of a corner case, because what you're doing is you have a stretch cluster and you're making an explicit decision that I don't want to replicate the storage for that VM. So the stretch cluster is capable of bringing that VM up on the other side and having storage, but you've said don't replicate the storage. And really that VM should live in a non-stretch cluster. And you've made a decision because it's a load balanced a web server, or you're using SQL replication or something like that. You've made a decision you don't want to replicate that at the storage level to the other side.
Yeah, perfect. Okay, moving on. I mentioned earlier that DPM is disabled, but we have something cooler. We call it elastic DRS. And what it does is it hooks into that same DPM engine. It uses the same baseline. We still go through the same polling system. We still go through the same thresholds to figure out where we are from a cluster availability perspective. But the way that we respond to those is a little bit different. So let's say we go through and we've got a workload that just kind of goes out of control and starts writing like crazy and creates a bunch of additional storage consumption. And we cross one of those thresholds where the DRS engine is coming through and taking a look, and it says, is my CPU exceeded? No. Okay. Has my memory exceeded? No. Okay. Well, has my storage exceeded? Yes. All right. Scale up and leverage the elasticity of Amazon on demand. Just automatically bring a host into the cluster, bringing those resource utilization back down. Now, later in the day, the administration team comes in, they look at their inbox. Oh crap, we scaled up last night. What happened? Start to take a look. Oh, well, the backup didn't run. The transaction logs never got flushed. The log consumption got way out of control. Let's go ahead and fix that. Once they bring that storage resource utilization back under the threshold, that same DPM DRS engine comes back through, this time with a set of AND rules, trying to judge whether or not it can reduce the cluster. Do I have excess? There we go. Nope. Here, thank you. Do I have excess CPU? Yes, I do. Do I have excess memory? Yes, I do. Do I have excess storage? Yes, I do. Well, therefore, it is safe for me to scale down, and we'll automatically reduce the scale of that cluster. The final little note on this is if we subsequently scale up or down twice in a 30-minute period, elastic DRS goes to sleep. And it does that because we don't want to just consume 16 hosts and give a customer a really big surprise bill, right? We'll do our best within reason, but we figure if you go more than 2 hosts in 30 minutes, you probably want to take a look at that as an operations team.
So to your point about not surprising the customer with a large bill, is
Yes.
this behavior configurable?
Absolutely. So the way, Absolutely. So the way that Elastic DRS works, by default, it is disabled and it only works on storage. So we ignore CPU and memory consumption, but we do monitor storage. And if the cluster gets to 75% full, we add a node. And we do that for stability reasons on the back end. Since vSAN is a shared nothing object store, we need free space to be able to guarantee availability. Now, if you enable DRS, we have two different modes. We have a performance bias mode, and then we've got a cost bias mode. Performance bias will add hosts faster and remove them slower. Cost bias will add hosts slower and remove them faster. And you give us a financial bounds for what you want your cluster to be, right? 3 to 7 hosts, and we just keep it within that range, ensuring that you're not using any more hosts than you actually need at that point in time. Right, so it's just an automatic way that we can just guarantee that customers are just going to not be wasting resources out of the box. We're going to do our best to make sure that you don't have a host in your cluster unless you're actually using it to host workload. Okay?
Can you, sorry.
Yeah.
All right. If storage is the thing that's coming under a restriction, you're running out of storage, rather than adding a host, wouldn't it make sense to add storage?
So it might in another world, but remember where we are. We're inside the AWS cloud, right? We're using HCI scaling semantics with a fixed host. How do I add a disk to an i3 metal host in the middle of some AWS data center when no one even knows where that host is, right? The controls that we have is to add a host, because that's how we add more storage into the cluster. And this gets into what Narayan was talking about with the roadmap, and I'll touch on later today when we get into the storage-specific sections. You'll see how the Elastic DRS engine works, how Elastic vSAN works. Today, its scaling semantics aren't exactly what you're talking about, but we're working to get it so that you can just add storage where we have those options. Now, in the options where the storage is in the box, again, the only thing we can do is add another box, because that's how we add storage. Is there another question? And then I need to quickly get going.
Yeah, it was around the same thing. So if you've got Elastic vSAN, then you're an EBS volume, and you can dynamically grow those. So
we could. There's a combination of technical limitations both on the AWS side and the VMware side that's preventing us from doing that today. As we'll see it a little bit later. Today we designate that capacity at cluster creation, but we're working together to be able to enable customers to be able to change it after the fact, adding some dynamically.
I think it's just worth clarifying, because the constraints make sense, but when you're saying the constraints are because storage is in the box, that's fine, but then it gets a bit confusing because
in the interest of time, because we're almost out of time in this section, I'm going to ask that we hold this one off until we get to the actual storage section. I will explain it then, and it will make sense. It's because of how it shows. Technically, it's remote, but as far as vSphere is concerned, it isn't. It looks as though it's local storage.
The EBS volume, that is.
Yes.
Yes, of course.
Yeah. All right, so finally, we need to know, regardless of all the settings and whatnot, in a lot of ways, the most important decision that you make as a customer when you bring a workload into the VMware Cloud and AWS service is simply what kind of cluster are you trying to deploy? And this really gets to what kind of problem are you trying to solve, right? Are we talking about our standard multi-host cluster where we deploy 3 to 16 nodes inside a single region, single availability zone, and then again, if Amazon were to suffer an AZ availability problem, we of course would have a problem on the cluster. When we're dealing with workloads that just can't tolerate that at all, where customers want to take those enterprise-class business-critical workloads and they want to deploy them inside the AWS cloud without refactoring, without replatforming, without any kind of, they just want to lift, shift, put it in there, and VMware deal with it for me. That's our stretch cluster offering, right? By introducing vSAN stretch clustering into the solution and replicating that data across multiple availability zones, this gives us the ability to survive an entire AZ outage, and it creates AZ failure or converts AZ failure into a standard HA restart event, right? Standard, basically a no-op. So one of the main advantages with the service, right? And again, we touched on this in the introduction today. So far, we've delivered 96% satisfaction from existing customers inside the service. The support is one of the biggest aspects of this. It's all provided by a single throat to choke. No need to worry about this. No need to go get into the complications, regardless of where you are in the product, whether it is inside Virtual Center, inside the cloud portal, anywhere in the product, there's a little help question mark in the top right corner. If you click that question mark, then our support panel pops out. From that single pane, we can search through the entirety of our KB and documentation to get quick access to all the online docs if we just want to RTFM and figure it out for ourselves. If we don't, we can conversely just ask VMware support, right? Hit that chat button and we'll come online and have a conversation with the customer. We also have links out to open up support requests as well as vForum community requests. So it's a nice single plane for you to be able to, regardless of what your challenge is, you always have the same muscle memory for how you're going to solve it. You just open up that support experience and ask VMware. We get online and we help you out. The last point is this service health. Again, since we are running a cloud-based service, cloud services require monitoring because you need to know, okay, well, is the cloud down? Is it the service instance down? In our case, this is all available through status.vmware-service.io. We get online monitoring and availability. We also have our maintenance history. So if you want to see our upcoming maintenance windows, when we're going to be bringing the service down for any reasons, as well as our history around outages, our actual downtime, et cetera, that is all available from the service panel.